I allowed you recording if you'd like to. طيب. This is the first question. Hello, Yanur. I allowed you recording. Yes, Abdurrahman, excellent. Okay, Noor, excellent. Alishba. Yes, Rudaina, excellent. Okay, who didn't answer? Minna? Minna, what's your answer? Type. Okay, the answer here is C. Why is it C? Why is it C? Because whenever you want to measure the percentage uncertainty in case of a thermometer, of course, you have to take two readings, the initial reading and the final reading, isn't it? So this means that the uncertainty measured should be multiplied by 2. So you say that the percentage uncertainty equals 2 times 0.5 divided by the measured temperature, which is 16, and then you say times 100, isn't it? So you will get 6.25, which is 6.3. Okay, you have any question here? Let's see the second question. The student repeats the experiment but burns 0.3 grams of methanol and uses 75 centimeter cube of water in the copper calorimeter. What is the expected temperature change in this repeat experiment? Okay, Alishba. Okay, Noor. Thanks, Alishba. Okay, Noor, Abdurrahman. Hello, Yatoga. Rodina, excellent. Hello, Yatoga, how are you? Type. Okay, now Rodina, how did you solve this question? Because the answer is, as Rodina said, it is 16. So how did you solve this, yeah, Rodina?
Miss, when I tried to do cross multiplication, it didn't work. So
Yes.
I just value that I got beforehand. So I just used the same value. I assumed it would be the same value because I wasn't sure how else to work it out.
Okay. I thought that you did something, Yani, to get the answer. Type. In the first time, hello, Yatoga. What did you do, Ya Abdurrahman, to get your answer? Because your answer was not, of course, correct, but what did you do to get it? The first, yes, yes.
I multiply by 1.5 because the mass of methanol increased by 1.5.
The mass of methanol increased by 1.5. It was, at the beginning, it was 0.2 grams and it increased to be 0.3 grams, isn't it?
Yes.
يعني 0.2 grams, and in the second case, it was 0.3 grams. And
multiplied also by 75 over 50.
okay,
because
this 0.2 was present in 50 centimeter cube, isn't it? And this was present in 75 centimeter cube. So you multiplied what back?
0.2 multiply 1.5.
Yes, the difference, you mean? Yani the relation between them, you mean, isn't it?
Yes. And by the increase of volume, which is 75 over 50.
Okay, this was 1 minute, please. Yani if you want to find out the ratio between the number of grams per centimeter cube and the number of grams per centimeter cube, you say that if this 0.3 grams is present in 75 centimeter cube, what will be the mass in 50 centimeter cube, isn't it? So by cross multiplication, you will get the mass equal to 0.2 grams, which means exactly the same as the previous one, which means that it should be a 16 also. Understand? So the answer should be 16, as Rodina said, because the ratio here between the volume, if you divide 75 by 50, you get 3 over 2, isn't it? The ratio here is 3 over 2. And here the ratio is also what? 0.3 divided by 0.2, you get also 3 over 2. So the ratio is the same. And the ratio between this volume and this volume and between the mass and this mass is the same ratio, which means that the increase in temperature will be the same. Understand me, or shall I repeat anything? Do you have any question? Okay. Let's see.
Miss,
Hello.
I don't
Yeah.
understand how you got 0.2.
I got 0.2 grams. It means I said 0.3 grams are present in 75 centimeter cube. So I want to compare this experiment with the previous one. I wanted to compare between them. So I said, if here we have a 75 centimeter cube at which 0.3 grams were dissolved. So what happens if we have 50 centimeter cube like the previous experiment? How many grams do we get? So I got the same grams as the previous experiment. Since the ratio between the grams and the ratio between the volumes are the same, this means that the temperature rise will also be the same. Okay.
Okay, Miss.
Okay,
Thank you.
you're welcome. Let's see number C. The students calculated enthalpy change of combustion of methanol is more exothermic than a data book value. What is a possible reason for this? Yes, excellent, Rodina. Noor, excellent. Alishba. Tuga. Abdurrahman. Minna, excellent. So who didn't answer? I think all of you answered. The answer here is D. Why is it D? Because we know that all these reasons would lead to a less exothermic than a data booklet, not to a more. All this, when there is heat loss to the surroundings or when we have an incomplete combustion of methanol, we usually say these reasons whenever they ask you why your value is lower than the value that is present in the data booklet. But here the value is more than the data booklet, which means that the student used the molar mass of ethanol except instead of that of methanol, ethanol instead of methanol. So the answer should be D. You understand me? The other reasons we usually say about them whenever we have an enthalpy change value which is lower than the enthalpy change that is present in the data booklet. Okay. Okay, thank you, Toga. Let's see number 2. Yes, excellent, Abdurrahman. Noor. Alishba. Minna, excellent. Rodina, excellent. No. Okay, who didn't answer? Yes, Noor, excellent. Okay, of course, the answer here is A. Why is it A? Because we all know that bromine physical state is a liquid, and the definition of the standard enthalpy change of atomization, we say it is the enthalpy change when 1 mole of a gaseous atom, when 1 mole of gaseous atoms is formed from its element in its standard physical state. So what is the physical state of bromine? It's liquid, it's not a gas, it's a liquid. And of course, since we need only 1 mole of bromine atoms, then we have to use half the bromine liquid. Okay? It's not bromine gas, it's bromine liquid. We know that fluorine, chlorine are present in the form of gases. Bromine is a liquid and iodine is a solid. Okay? Number 3. Noor, is that your answer or the previous one? Yes, Rodina, excellent. Is it your answer or was it the answer of the previous question? Okay, Noor, thank you. Yes, excellent, Noor. Abdurrahman, why Abdurrahman? Think once more. What is the delta H naught of the reaction when it is calculated using bond energies? What do you do? Yes, that's correct. Minna, excellent. Alishba, excellent. Toga, excellent. So I think all of you answered, and A is the correct answer. We usually do the bond energies of the reactants minus that of the products, not the opposite. We said that if we are using bond energies, or they gave us information about the enthalpy change of combustion of the reactants and products. So here we say that the delta H naught of the reaction is equal to the reactants minus the products. Either we have bond energies or enthalpy change of combustion. But if they give us information of delta H naught of formation, that in this case, the delta H naught of the reaction is equal to products minus reactants. The enthalpy change of formation of the products minus that of the reactants. Yes, excellent all. Now, number 4, which compound has London forces as the only intermolecular force? Toga, is that the answer of this question? Number 4. Okay. Rodina? Yes, that's correct, Rodina. Abdurrahman, excellent. Noor, excellent. Alishba. Minna. Tuga. Okay. No, this is not unit 1, ya Alishba. We are going to do it in unit 1, not here. Type. Okay, the answer here is D. Why is it D? Why the answer is D? Why the answer is D? Because we know that intermolecular forces of attraction, they said only London forces What about the hydrogen fluoride? Someone of you answered hydrogen fluoride. We know that when we have a hydrogen directly bonded to a fluorine, or a hydrogen bonded directly to an oxygen, or a hydrogen bonded directly to a nitrogen, then we have what we call a hydrogen bond, isn't it? So which means that hydrogen fluoride molecules are bonded together by hydrogen bonds together with London forces. But they said only London forces, which means that you must have a non-polar molecule. Now, for the oxygen difluoride, it is not non-polar because we have oxygen and we have two fluorine atoms bonded to it. And we know that the fluorine atoms are more, of course, this is, it has this shape, which is the band shape or the V shape, because due to the presence of the lone pair of electrons on the oxygen. And we know that fluorine is more electronegative than oxygen. Okay, Alishba, I'm just explaining now what is polarity. So if you have a fluorine atom, which is more electronegative than the oxygen, it will withdraw the electrons away from the oxygen, and the second fluorine will do the same. And so as a resultant, you will have a polarity that that is downward. You have a polarity for the whole molecule that is in the downward position or in the downward direction, which means that this molecule is a polar. And when it is polar, it is bonded to another molecule by permanent dipole-dipole interactions, isn't it? So the type of bonding here between the molecules, although we have fluorine and oxygen, but we do not have hydrogen bonded to any one of them. So the type of intermolecular force of attraction here is permanent dipole interaction. So also this is incorrect. Now for the third one, because more than one of you answered C. Now phosphorus is present in group 5. And when it is present in group 5 and it did only 3 bonds, so it has a lone pair of electrons still present on the phosphorus, which means that the shape here is trigonal pyramidal. It's trigonal pyramidal, not trigonal planar. And so it's not bonded by London forces only, because also here the phosphorus is pulling, the fluorine is pulling the electrons away from the phosphorus. And so also this is a polar molecule bonded together by permanent dipole-dipole interaction. Now we are left with the carbon, the tetrafluorocarbon, which has a symmetrical shape where we have a tetrahedral with 4 fluorine atoms bonded to the carbon, and all fluorine atoms are similar in electronegativity. So all of them are pulling with the same strength in different directions. And since the molecule is a symmetrical one, then it's a non-polar molecule. And this means that the only type of intermolecular force of attraction that is present here is the London forces, because every two fluorine atoms are pulling in a direction. It means that the resultant of these two is pulled in this direction, and the resultant of the other 2 fluorine is pulling in the opposite direction with the same strength, so they cancel the effect of each other. Okay, do you have any question here? Because more than one of you asked me to explain this. So do you have any question here?
Miss?
Yes.
So whenever there's a lone pair present, it's always permanent dipole?
No, it depends on the shape of the molecule. It depends whether you have an electronegative atom, and it depends whether you have the shape of the molecule depends what happens, and also the presence of electronegative atoms or not. Okay, so here it was a polar molecule because the shape is trigonal pyramidal, and you have the fluorine atoms more electronegative than the phosphorus. So this means that the dipole will be in this direction. Okay, it will pull the electrons downward. Understand me, Rudaina? It depends whether you have electronegative atoms or not, and depends on the shape as well, not only on the lone pair of electrons. The lone pair of electrons determines the shape.
Okay, thank you, Miss.
You're welcome, because this is not trigonal planar. If there were no lone pair of electrons, then the shape would have been trigonal planar, and in this case, it will be a non-polar molecule bonded together by London forces. But this is not the case, because phosphorus has a lone pair, so the lone pair determines the shape, and from the shape we can determine whether we have a nonpolar molecule as a whole or not. Okay.
Yeah, thank you, Miss.
You're welcome, Dee. Number 5, which compound has intermolecular hydrogen bonding? You see, they are asking you about the intermolecular forces of attraction that we studied in Unit 2, but it depends on the shape that we studied on Unit 1. In the previous, in the previous problem question. Yes, Alishba, excellent. Abdurrahman, excellent. Noor, excellent. Minna, excellent. Rodaina, excellent. Toga. It's 4:30, Alish. You're welcome. Toga, what's your answer here? Okay, it should be C. Why is it C? Because we said that hydrogen bonding takes place whenever we have a hydrogen that is directly bonded to a fluorine in a molecule, or a hydrogen that is directly bonded to an oxygen. You have to know this, or a hydrogen bonded to a nitrogen. So we don't have here any hydrogens bonded to the fluorine or the nitrogen, so these are out. Now, what about this one? This one is an aldehyde. We know that an aldehyde means that you have a carbon that is bonded here to 3-methyl. It doesn't depend on this part, but as you see, this is an aldehyde. So it is a C double bond OH. The hydrogen is bonded to the carbon, not to the oxygen. You have an aldehyde. This is an aldehyde group, C double bond OH. So this means that the hydrogen is bonded to a carbon, not directly to an oxygen. So also this is out. But this is an alcohol. An alcohol means that you have a CH3 bonded to 3 CH3s bonded to the same carbon, and then you have an OH. So here the hydrogen is bonded directly to the oxygen, which means that it will be, the molecule as a whole will be bonded to each other by hydrogen bond. Okay, any question? Let's see number 6. Which sequence shows the hydrogen halides in order of decreasing boiling temperature? Decreasing, not increasing. Take care. Abdurrahman, I said decreasing, not increasing. Take care, ya Abdurrahman. They wrote it in bold. Yes, that's correct. Okay, Noor. Think once more, ya Noor. Alishba, think once more. Okay, Toga, think once more. You forgot a very important thing. Rodina, what's your answer? Amanna Tariq. Yes, ya Abdurrahman, that's correct. Rodina, excellent. Minna Tariq, excellent. The answer here is B. Why is it B? Because you remember that we said that if we have hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide, we said that if we look at these, the molecules are bonded together mainly by London forces, mainly. And we said that London forces, the strength, we said that the strength of London forces increases by the increase in number of electrons, increases by the increase in the number of electrons that are present in the molecule. So of course, hydrogen iodide has more electrons than hydrogen bromide, and hydrogen bromide has more electrons than hydrogen chloride, which means that the boiling temperature will increase in this direction. So if we are drawing, if you remember, when we have drawn the hydrogen fluoride, hydrogen chloride, hydrogen bromide, and hydrogen iodide together with the boiling temperature, we said that the boiling temperature of the hydrogen iodide is the greatest because it has the greatest number of electrons. And so the intermolecular forces here is the greatest, I mean the London forces. And so it will have the highest boiling temperature, followed by the hydrogen bromide, followed by the hydrogen chloride. And it was supposed for the hydrogen fluoride to be here, lower than the hydrogen chloride. But due to the hydrogen bonding, it was the greatest. The boiling temperature of hydrogen fluoride was the biggest because it has hydrogen bonding. And we said that the hydrogen bonding would assist the increase in the boiling temperature. And we took the same trend in case of water with its group. We took the same trend with ammonia with its group, isn't it? So you have to take care that only the one that causes or forms the hydrogen bonding is the one that will have the highest boiling temperature, and then followed by the increase in number of electrons, because it depends on the increase in the number of electrons. It depends the strength of the London forces. Okay, so the B is the correct answer. Type number 7. Which ion? If you have a question, please ask. Number 7, which ion contains vanadium with an oxidation number of +4? Rodina, excellent. Abdurrahman, excellent. Was it your answers for this question, or I thought something wrong? Yes, Alishba, excellent. Yes, okay, Abdurrahman, excellent. Minna, excellent. Noor, think once more, ya Noor. Yes, what about the others? Toga, what's your answer? Okay. The answer here is A. Why is it A? Because if you take VO +2, we said that the oxygen is -2, is always -2, except if it is present with a fluorine or as a peroxide. Here it is neither this nor that. And this means that the vanadium here should be +4, because if you add +4 to -2, you will get +2. So the answer is A. Okay. Now, what is the formula of potassium manganese 6? Yes, Yanur, excellent. Minatari, is it your answer here? Well, the previous question, I think. Okay. Alishba? Abdurrahman, excellent. Toga, excellent. Minna, excellent. Okay, I will tell you. What about the answers of the others? Type. Okay, the answer here, as most of you said, it's B. Why is it B? Because they said potassium manganate 6. It means that the manganese has a +6 charge, isn't it? This is what they wrote. Manganese 6 means that the manganese should have a +6. So if you take B, it is K2MnO4. So you have 4 oxygens. And we said that oxygen always has a charge of -2 or an oxidation number of -2 as long as it is not bonded to a fluorine or to a peroxide. So it's -8 altogether, 4 oxygens by -8. And we have 2 potassiums. And we said that each potassium, any group 1 element, should have a valency or an oxidation number of +1. So altogether, this means that for potassium, it is +2. So +2 plus how much? -8 would give us 0. The charge here is 0. So this means that manganese here should be +6. So if you add +6 +2, you -8, you get 0. Okay. But for the potassium MnO4, when we had KMnO4, this means that you have 4 oxygens times -2 makes -8. This is +1, which means that the manganese here should be +7. So here the manganese has an oxidation number +7, but here it's +6. Okay, understand how do we do it? Of course, this will be +5. And here, if we want to calculate for here, it is K6Mn2O6. So you have 6 oxygens. 6 times -2 makes -12. And you have 6 potassiums by +6. This means that both manganese have a +6, because +6 +6 -12 makes 0. The total charge on the molecule is 0, which means that every manganese has a +3, because whenever they ask you about the oxidation number of an element, you get for only one atom, not for both. So here the manganese has a +3. Okay. Understand this, or do you have any question? Let's see number 9. Yes, excellent. Excellent, Abdurrahman. Noor. Noor, you thought about something and you left the others. You too, Alishba. Toga, excellent. You have to answer more quickly. I told you before. Noor, Rodina. Okay, Rodina. Noor, excellent. Alishba, did you answer? Yes, you answered, but it's not correct. Type, okay. So the answer here is C. Why is it C? Because they said that a red color is produced in the flame test. Many of you answered A. Okay, yes, lithium gives a red color in the flame test, but it does not give a white precipitate with potassium sulfate. If it reacts with potassium sulfate, what do we get? If you have potassium sulfate reacting with lithium chloride plus potassium sulfate, what do you get? You get lithium sulfate, isn't it? Plus potassium chloride, isn't it? You will get lithium sulfate. Is lithium sulfate a precipitate? Of course not, because we all know that all group 1 compounds are soluble. All group 1 compounds, just as potassium sulfate is soluble, also lithium sulfate is soluble. All group 1 compounds are soluble. So yes, it will give a red color in the flame test, but it will not form a white precipitate with potassium sulfate. So we only have barium and strontium that can form white precipitates with potassium sulfate. But of course, we know that barium in the flame test gives a green color, a yellowish green color, or we call it an apple green color. So it's not the one that we choose. We choose this, the strontium, because also strontium gives a red color in the flame test. Okay. Any question? Type number 10. Which reaction produces more than one product? Yes, Menna, excellent. Abdurrahman, excellent. Noor, excellent. I don't know, yeah, Rodina, is this the answer of the previous question or this one? Menna,
No.
Tare, excellent. Yes,
This is my answer, the last
this
one.
is your answer. Okay, Alishba. Okay, Rodina, excellent. Toga, excellent. So the answer here is C. The answer here is C. Why is it C? Because if you take magnesium plus oxygen, it gives magnesium oxide as the only product. So it's only one product. They said which will give more than one product. For calcium plus chlorine, it will give calcium chloride. Of course, here you have to balance the equation to get magnesium oxide as the only product. For barium oxide plus water, you get barium hydroxide, isn't it? So the barium with water gives barium hydroxide. But here for strontium, what do you get for strontium? Who will say? Strontium plus water, what do we get? Yeah.
اللي هو strontium hydroxide to H2
Yes,
hydrogen.
excellent. Excellent. You get strontium hydroxide plus hydrogen. So here we get strontium hydroxide plus hydrogen. So you get two products, not only one. Okay. Type. Yes, excellent, Abdurrahman. Yes, excellent. Type. Okay, let's see number 11. Yes, excellent. Abdurrahman, excellent. Okay, Noor. Rodina, excellent. Please think more quickly. Toga, excellent. Min and Alishba. Min, excellent. Okay, the answer here is D. Why is it D? We know that the order of reactivity is fluorine, chlorine, bromine, iodine, and at the end we have astatine, isn't it? We said that the more reactive displaces, the less reactive from its compound. So here, if you react iodine with astatine, which is more reactive? The iodine is more reactive than the astatine, which means that it can displace it. And so we get the iodide plus astatine. So this is correct, isn't it? Iodine is more reactive than astatine. If we look here, bromide plus chlorine, they made the trick here because they wrote the bromide first and then the chlorine. It doesn't matter, but you have a chlorine. The chlorine is more reactive than the bromine, which means that it can displace it from its salt. If we have chlorine and iodide, it's the same as the previous one. The chlorine is more reactive than the iodine. So we are left with the fluoride plus astatine. Astatine is the least one in reactivity. Can it displace the fluorine, which is the most one in reactivity? Of course not. So this is the correct answer. It's D. Okay. Let's see number 12. This is the reaction that I told you always, always, always come in exams, always. So you have to know it at once. Okay, يا نور. يعني it's even previous يعني from the equations in front of you. Okay. Yes, يا رودينا, excellent. Where are your answers يا جماعة؟ عبد الرحمن, Alishba, Minna. Yes, عبد الرحمن, excellent. Tuga, excellent. Alishba, excellent. Okay. Minna, excellent. Yes. So all of you answered D, and this is the correct answer, because we know, all of us know, that whenever we have a chloride, since the chloride has the least reducing power, so it's not going to be oxidized by the sulfuric acid. It has the least reducing power compared to the bromide and the iodide. We took these reactions of chlorides with sulfuric acid. I told you it could be in the form of sodium chloride, potassium chloride, magnesium chloride, anything containing chloride with sulfuric acid. Then the reaction will be at the beginning a displacement reaction. It will not be an oxidation reduction. But starting from bromide, after it produces in the first step the potassium hydrogen sulfate and the hydrogen bromide, as the hydrogen bromide is a stronger reducing agent than the hydrogen chloride, then the reaction will continue as an oxidation reduction reaction, and we get the bromine plus the choking smell gas of SO2 plus water. And since the potassium iodide reacting with sulfuric acid would produce potassium hydrogen sulfate plus hydrogen iodide, and since the hydrogen iodide is the strongest reducing agent of them all, so it's going to do, as you remember, it did 3 different reactions, producing iodine, producing sulfur dioxide, producing H2S gas, producing sulfur yellow solid. Do you remember these equations or not? And of course, since hydrogen chloride is a least reducing agent compared to this means that hydrogen fluoride also is a least reducing agent. It cannot react as a reducing agent with sulfuric acid. So these two will not be oxidized. The reaction will stop in after only one step. But for the hydrogen bromide, it will continue with one more step. So the bromide will be oxidized to bromine, and the iodide will be oxidized in more than one step. But it's the potassium iodide. So I told you that this reaction is very, very, very important. All the exams, they must ask you about it, either in the multiple choice questions or in the others. So please take care for these reactions. All the reactions of the halides are very important. Do you have any question in number 12? Type, let's see 13. Silver nitrate in aqueous ethanol is added separately to 4 halogenoalkanes, which would form a silver halide precipitate in the shortest time. Yes, Abdurrahman, excellent. Minna Tari, excellent. Alishba. Alishba, we have 2 factors affecting, not only one. So please think once more. Yes, Yanur, excellent. Rodina, excellent. Toga. Yes. Of course, Yani, your answer is excellent. So the answer here is A. Why is it A? Because we said that there are 2 factors affecting. We have, of course, as the radius of the halide gets bigger, this means that the bond between the carbon and the iodide will be the weakest. So the electrons here between the carbon and the iodide will be the weakest because the electrons are far away from the positive nucleus of the iodide, which means that this bond is the weakest. And so it's the one to be broken faster. And so the rate of the iodide, yes, is faster, but there is another factor that we said that whenever we have a compound like this one, it is CH3, it is a tertiary carbon. The iodide is bonded to a tertiary carbon. And since it is bonded to a tertiary carbon, it will be more easier to be broken, much more easier to be broken than whenever we have a chain alkane like this. In both cases, the iodide is bonded to a carbon. Here it's bonded to a carbon, and here it's also bonded to a carbon. But whenever we have a tertiary halogenoalkane, it's bonded more, it's broken more easier, the carbon iodide bond, than when we have a chain alkane. Okay, so the answer is A. Right, let's see 14. Yes, Yanur, excellent. Rodaina, Abdurrahman, excellent. No, sorry. You have to think once more. Sorry. Okay, Toga. Okay, who didn't answer? Okay, Minna. Now we said that what happens when we react any halogenoalkane with ethanolic potassium hydroxide? Elimination reaction takes place, isn't it? And this means that elimination means that the bromide comes out from a carbon together with the hydrogen from a neighbor carbon, isn't it? So here, if the bromide comes out with this hydrogen, we will get the alkene, which is CH3, CH double bond, CH, and then we have a CH2, CH2, CH3, isn't it? And since here we have a double bond, we said that we have to think about a cis, trans, or easy isomers. Of course, here we have one of them is the E isomer, where the molecules that are having the greatest molecular mass are bonded, are in the same, are in opposite directions to each other. And we also have the Z isomer. Now, what happens if the bromide comes out with this hydrogen? What do we get? We get a CH3, CH2, CH double bond, CH, CH2, CH3. So also we have a cis and trans isomer or EUZ isomer. So we have 4 isomers, not only 3. Okay. Understand why they are 4, not 3? Did you think about number 15? Please make your calculations more quickly. Yes, Rodina, excellent. Alishba. Only Rodina answered correctly. Yes. What about the others? Abdurrahman, Minna, Noor, Toga. Where are your answers? Yes, ya Noor, excellent. Abdurrahman, excellent. Minna, where's your answer, Yemen? Okay, Alishba, what did you do to write this answer that you did? What did you, yani, what are you going to do to find the least likely to have a peak at 43? Would you please answer me, Alishba? What do you do to find out the mass over Z equal 43? Yes, Yatoga, excellent. Hmm? Okay, would you please, yani, tell me what you did? You calculated the molecular mass of all the molecule? No, we don't have to do that. We don't have to do that, because if you calculated the molecular mass of this whole molecule, did you get 43? You said the answer is A, or what did you say? I think you said the answer is A, isn't it? So why did you choose A if you didn't get 43 for the whole molecular mass? We said that the molecular mass gives us what we call the molecular ion peak, that is the last The molecular ion peak is the last peak that we get in the mass spectrum, and this gives us the molecular mass of the compound, and we call this the molecular ion peak, isn't it? And then we said that the molecule starts to make fragmentation. What do we mean by fragmentation? Fragmentation means that it starts to break down. And when it breaks down, it will give us positive ions when it breaks, isn't it? So when you search about this 43, it means that maybe you have to, of course, find the total molecular mass, maybe. So if you calculated the molecular mass here, you will find 43 plus 29, you will get 72. It's not 43. If you calculated the molecular mass for all of them, you are not going to get 43 at all. So how do we get this 43? We break the molecules. We start to break the molecules and find out whether they will give us a mass over charge 43 or not. We call it fragmentation, isn't it? We are going to break the molecules. So for the first one, if you break the molecule here, so you will get a CH3CO positive. And if you calculated the M over Z of this ion, you will get 2 carbons, 24 plus 16 oxygen plus 3, you will get 43. But they said which is the least likely. It means that will not produce. Break in everywhere you can. Yani I started by the middle, but if you break it here, what you will get? You will get a CH3 positive and you will get a CH3COCH2. You calculate all these. You can calculate all these to find out whether you will get a 43 or not. You make fragmentation in every part in the molecule, okay, Alishba? But of course, maybe because from our practice, we know that the CH3 would give us a 15, a CH2, CH3 would give us a 29. So I didn't start with this. But you have, if you have time, you have to, you should have time. So you have to calculate every part. So try by breaking in the middle and then see whether it will give you something or not. So this will give us 43. Now, what if we, because the answer is B, I'm going to leave it till the end. Now, what if you break this molecule to this part, CH3, CH positive, this will give you 28. 24 for 2 carbons, 24 and 4 hydrogens, it's 24. So it's not correct. It's not the 43. If you try the CH3 times 2, this means 15 times 2, it's 30. So it's also not correct. But what if you take this part? You take the CH3, 2. So here you have 3 carbon atoms having 63. You have 6 and 1 hydrogen, so 7. So it will give you 43. So this will give 43. Okay, so this will give. Understand me, Alishba, or do you have any question?
Miss, for A, you got 43 and 29. So why isn't that one correct?
Because they said the least likely. It means that it will not form a 43. So this will give a 43, this will give a 43, and this also, if you break it in this part, also it will give you CH3, CH2, CH2 positive, which means also 43. So all these will bring 43. The only one that will not produce a 43 will be B. Understand now why?
Yeah, okay, thank you, Miss.
Okay, you're welcome. Now let's see number 16. Which compound has peaks at 3,415 and 2,250 centimeter minus 1 in its infrared spectrum? Of course, you have to use your data booklet. Do you have your data booklets with you? Okay. Do you have the data booklet with you? They said, where is it? They said, which compound has peaks at 3000? Yes, excellent, Rodina. Which compound has peaks at 3415? So I'm going to write them here. 3415 and 2250 centimeter minus 1 in the infrared spectrum. So we have to look in the data booklet. This peak 3415, where is it present? So I found one here. It is an NH, either an NH stretching or elsewhere. Do we have any other? For the OH, it's also, for OH, also it has a peak between 3200 and 3750. So we have two peaks. Now, what about the 2250? Let's see.
Miss, I think that one's the triple bond, the C triple bond N.
You didn't find it?
I did. It's for
Okay.
two.
Yes, excellent. It's this one. The C triple bond N. It has a peak between 2260 and 2215, which our peak is also present. So as Rodina said, now we have two peaks. Here it said that we have two peaks. One of them, why is it not C double bond C? Let us see where is the C double bond C. The C double bond C is where, Alishba? It's in the 1669 to 1645. Do you have a peak in this part?
No, Miss. I was saying, you know where there was a C triple bond N?
Yes.
Underneath it, there was a C double bond C.
I didn't say a C double bond C. You said,
No,
not me.
Yeah, no. Underneath, on the data booklet, underneath the.
You have here a C
Yeah, a
triple
triple
bond
bond.
C.
Sorry.
So this
Yeah.
is a C triple bond C. Okay, so also Alishba is saying that we have the C triple bond C, isn't it? Then you have to compare between the peaks that you got, because here also we have two choices, isn't it, Alishba? We have two choices
yeah.
here, either an NH or an OH, and here we have a C triple bond or a C triple bond C. So here you have a C triple bond C, but you don't have neither is an NH or an OH, which means that this compound is not one that we are going to choose. Understand me why? Yes, you can get this peak corresponding to the C triple bond C, but we do not have a peak corresponding to the carbon chlorine. We have a peak corresponding to an NH or an OH, which is not present here in this molecule. Understand me why we didn't choose this?
Yes, Miss. Thank you.
Okay, you're welcome. So we have to choose A because it contains a C triple bond N and it contains NH2 as well. So the answer will be A. Okay, do you have any question?